Hi, in this video we will discuss another question of interview preparation marathon contest 4, which was recursion. We have already solved few questions. You can see that in our YouTube channel. Now let's just go into and solve the problems. Before that, as you can see, we have already had 4 contests. In case you want to solve the problems, you can solve it from here and make sure you participate in the upcoming contests as well. You can see the complete schedule of interview preparation marathon over here. Now let's get into the recursion contest. So we are going to solve mic and binary number. Let's just go ahead and solve this. So since the contest has ended, the practice is moved to practice section. Let's go to practice section. So now let's first try to understand the problem statement. We'll first understand the problem statement, then we'll try and come up with the logic, we'll solve the test cases, and then we will see how to come up with the recurrence relation, what is going to be the base condition and how to write the code. We'll see all of that, but since the most important thing is understanding the question, let's just go ahead and do that. So the question says, the question name is Mike and binary number. Mike loves solving binary number problems. So he gives you a number n and asks you to find the binary representation of n. Okay, but he thinks this is easy for you. Obviously, if you're solving question of recursion, finding binary number must be a cakewalk for you by now. So he added one more condition to this problem. Now he asks to find all the possible permutation of the binary representation of number n. Okay, so I'll just repeat what is it said. He gives you a number n and asks you to find the binary representation of n, but he thinks this is easy for you, so he added one more condition to this problem. Now he asks you to find all the binary permutation of binary representation of number n. So let's see the example. Example for n equal to 5, binary representation is going to be 101, and we see we used these digits that's there in 101. This obviously there are only 2 digits, 1 and 0. So 1 is occurring 2 times, 0 is occurring 1 time, and we have used this particular thing to see that what are the different possible permutation possible out of this particular set. And as you can see, these are the permutations. Now what we have to do is that we have to print the output in the lexicographically sorted form. Fine. So this is a small note here that you should solve this question using recursion. Anyways, if you solve this question using recursion, it will be much more compact and easy than. So now let's just see the input and output format. In input, the first line of the input contains an integer t, denoting the number of test cases. For each test case, the input contains an integer n. So let's just see the test cases. So here this is going to be my t, this is my n, and this is my n. This is my input. Output, for each test case on a new line, print the permutation separated by space. So in this case, for 2, we know the binary representation of 2 is going to be 1, 0, and as you can see, the permutation of this 1, 0 possible is 0, 1 as well. And since we have to print in lexicographically sorted order, we have printed it this way. Similarly, for 8, what is going to be the binary representation? It's going to be 1, 000. Now we have printed all the permutation of this particular digit, this particular binary number in this particular format over here. So what are the different permutations if you see? So we have 3 zeros and 1 1. So we are going to have 1 000, we will have 0 1 00, we will have 0 0 1 0, and we will have 0 0 0 1. These are the 4 permutations that's possible. Okay, so now I hope you have understood the question. Just keep in mind, you have to first find the binary number, a binary representation of the number, then you have to just print all the permutations. And as we already know that this is a recursion contest, so you have to solve the problem using recursion. First try and solve this problem, first try and solve the test cases. See what are the possibilities, see what are the different possibilities that you have to take care of, and then try and generalize those possibilities. Don't worry, you'll be able to do it. First try on your own. In case you aren't able to do it, obviously we are going to discuss, so you can come back and see. Okay, so I hope you tried solving the problem on your own. In case you were able to solve the problem, amazing, you can solve other problems in the practice section. In case you haven't, make sure you watch this video, you see how the problem is getting solved, and you solve other problems of recursion as well with the same approach or same thought process. Okay, so now let's see. The question was that you'll be given a number n, you have to convert it into a binary form, and you have to just print all the permutation of the binary form that was there, and it has to be in a lexicographically sorted order. Okay, so let's see how the number is going to be. It is going to be 1101, 101, 100. So now let's see this number. If I have to print all the permutation of this number, at the end of the day, I know the number will either have 1 or 0. Okay, so if you see what are the different combinations of this particular number is possible. So basically it is going to be the number of ones we have and number of zeros we have. we will just be bothered about that. Okay, so let's say in this case it's 1001. Okay, or let's say there's another binary form that is 1010. Okay, so the binary form of these two is different, but at the end of the day you will see that the permutation of both of them will be same. Why? Because the number of ones and zeros is equal in both these cases. So at the end we are just bothered about the number of ones and zeros that is just there in the number. Okay, so now let's say I know the ones and zeros. What do I need to do? So now if I know the number of ones and zeros with me, the problem boils down to that you are given the number of ones and you are given the number of zeros. You have to just tell me that what are the different permutations possible. Okay, so let's say I have to make a string of length 4 containing 1 and 0. So like we know in case of recursion, as I said, see the possibilities. What are the different possibilities? So for every place we have two possibility, that we either put 1 or 0, we either put 1 or 0, we either put 1 or 0, we either put 1 and 0. Do I have any other possibility over here? No, I don't have any other possibility. So one thing I know is that I just have to bother about count of ones and zeros. Second thing is that at each place I have two options. I either place 0 or 1. So till now I know these particular stuffs. Okay, now let's say what else is there. Now let's see what else is there. So now as I said that we can either place 0 or 1. Okay, so now we saw that we have to do it in a lexicographically order. So what I'll do is that I'll start with 0. Okay, I'll start putting 0. Let's say this is the thing. Let's say my stuff was this. Let's say this was my original binary number, binary representation. So I'll put 0 here, I'll put 0 here, I'll put 0 here, I'll put 0 here, I'll put 1 here in the beginning. Now what happens is that now I have to try that this 1 can go to any other place also, right? So let's say I put 0 here, 0 here, 0 here. I know that at this particular place I cannot put anything but 1 because my number of zeros are over. So what I am doing is that I am putting 0, I am continuously putting 0 unless I have number of zeros with me, and as soon as 0 is over I started putting 1. Now I have added 1 here, there is no change that is happening. If I put 1 here it will be same, right? So what I'll do is that I'll go to this particular place. Okay, so now let's say I'm going to be 0 0. At this particular place I have already put 1 0, so I'll put 1. Okay, so now let's say I put 1 here, I'll again go ahead and I'll see what could be done. So at this place what are the options that we have? Again, since I have only 1 1 and I have already used that, I'll put 0 here. Okay, so now this is one possibility. Now what else I'll do? Since I have already taken care of this place, I have taken care of this place, what I'll do is that I'll go one place back. Okay, I'll do 0, I'll put 1, again I'll put 0 and 0. Okay, now what I'll do is that I'll come here, I'll put 1, I'll put 0, 0 and 0. Okay, so just solve it. I'm just solving the test cases. I'm not saying this is the logic, that is the logic. I'm solving the test cases. Let's just solve the test cases and see what could happen. Let's take some other example. Now let's say my string is 1010. Okay, number of zeros is 2. We have 2 zeros, we have 2 ones. So again we'll start with 0. Let's start putting 0. So we added 0, we added 0 here. Okay, now what happens here? I have no option of putting 0. Why? Because number of zeros is over for me. So I'll simply put 1. Here again I have no option but to put 1 because number of zeros is over for me. So I put 1 here again. Okay, now let's see, I filled all the places. Now what I'll do is that once I fill all the places, so now I have already this particular string. To generate any other combination, I was here, right? What I'll do is that I'll start going back. Okay, so now I was here. Do I have any other, first before going back I'll check, do I have any other option for this place? As of now in this particular arena, if I see this place, I have no other option. So now let's say once I have generated one of the strings, what I'll do is that from last place I'll start looking for the other options. Okay, so here I see that do I have any other option? No. Why? Because my 0 is already over. Here any other option? No, 0 is over. Here do I have any other option? Yes, I have already tried 0. Maybe I try putting 1. So what I'll do is that I have 0 1. So now a new sequence of strings is going to be generated based on the one that has been put here. Okay, so now when I come here again I have two options because I'm left with 1 0 1 1. Okay, so as I said that I'll always prefer 0 1 because I have to do it in a sorted form. Okay, so I put 0 here. Now I again go here. Do I have any other option possible? No, I just have to put 1. So I'll add 1. Okay, now this is one option that was possible. So in this case, here do I have any other option? No. Here do I have any other option? Yes. What I can do is that here I can put 1. I tried for 0 here, I didn't try for 1. So let's do that. So we have 0, 1, 1. So once I have done that, here I have just one option, I put 0. Cool. Now let's see what else is the thing. So I already have this string, this string, this string. Here do I have any other option? No, I can't put anything else. Here I have already tried 0 and 1. Now I'll go back here. Here I tried 1. Here can I put 0? So if I put 0, I'll be going back to this particular place. So now I'll come back here. Okay. So here I have already tried 0. Let me try 1. Okay. So I'll put 1 here. Here I have the two options 1 and 0. I'll put 1, 0. Here again I have two options 1 and 0. I'll put 0. Here again I have two options 1 and 0. But obviously here number of zeros is over. So I'll simply put 1. Okay. So now one thing I'm telling you, so if you see what are the steps we are following, just try and just hold for a moment and try and write the steps. So what I did was that I started with str, putting str index as 0. So at any point I am giving first priority to 0. Okay, if I haven't tried, if I have two options 0 and 1, I'll put 0. If I have already used 0 there, I'll put 1. So I gave priority to str index as 0. Then what are the steps we did? I checked that am I available with more number of zeros or 1. So let's say I check if zeros and 1s are available. Okay. So let's say if the number of zeros is over, I have no option but to put all the remaining places as 1s or vice versa. Okay. I'm not telling this is the exact thing. I'm just writing down my findings. Okay. And then what I'll do is that once I have tried one permutation, I will go back and try the other options. Okay, so these are my findings. So now let's try and find exact logic for this particular thing. Okay, so now let's try and find the logic exactly. So what I'll do is that first of all I will keep on putting my value as 0. So what I'll do is that let's say the function is func. Okay, we'll see what are going to be the parameters. So let's say one parameter definitely is going to be the string. So let's say this is the string that we are building. So what I'll do is that, as I said, that we kept on putting 0 initially. We kept on putting 0 initially, and we need string to take care of this complete string, and then we need an index. Index is basically the place. If you see, we are taking care of each and every place individually. So index is the place where we are putting the value right now. So we'll put index. Okay. Now let's see. In the beginning, what we did str index equal to 0. Okay, and index having initial value as 0. Okay, now once I have done this, I have put this place as 0. What I'll do is that I'll call this function again, and we'll decide for this particular place. Okay, so now what I'll do is that, what I'm doing is that I'm filling for this particular place and I'm calling the function again to take care of the rest of the strings. Okay, so let's say I call function again, I do like str, and then what I'll do is that I'll increment my index, make it index plus 1. Okay, we'll see if we need any other parameter as of now. Okay, so now I do that, right? So now again I go again here. Now 0 is added here. So let's say the number of zeros we had was only 2. So we need two parameters, number of zeros, let's call it z, and number of ones, let's call it o. Okay, so now as soon as I put 0 here, I'll reduce the number of 0, I'll make it z minus 1, and 1 remains as it is. So now after this, what happens is that we put 0 here, let's say it gets called again, we put 0 here. Again what will happen is that once I put 0, this index plus 1, z minus 1 happens, the function gets called again. Okay, now at this particular place, when I'm here, I am done with my number of zeros. I'm done with my number of zeros, I have already ones left. So for rest of these places, I have no options but to put the number of ones. So I'll run a loop here. Okay, I'll run a loop here that will do nothing but just fill the rest of the places with 1. Okay, now I have done that and I have tried for 0. Now what else is the option? So let's say what happens is that, let's say 1 gets filled here, and as soon as the loop happens, we return. So let's say eventually we return back to this particular place. For here I have already tried 0. Let's say when I come back to this place, I have already tried 0 and I have to put 1. Now for putting 1 at this particular place, what do I need to do is that I need to line another line of code 1. Okay, and then I put 1 here. So since I have added 1 here, now my function, this particular function call will be func str index plus 1. Z will remain as it is. Why? Because we are not changing z's, and o will become o minus 1. Okay, now So what will happen is that, again, let's say this is a condition 0, 1. Again here we will put 0 because this comes first, and now here I have one option, just 1. Now let's say at some point I have already taken care here that what if number of zeros get over. Similarly, we have to have a loop that decides that what if number of ones got over. In that case, we will simply have similar loop for 1. Okay, so you know what, this is how I step by step completed my code. I saw what was my learning till date, and this is how I have done it on pen and paper, and this is very, very rough. Now I'll try proper code, and then I'll write the code in a IDE. Okay, so now let's try and write the code. So let's say the function is binary num. Let's say it has string str. I'm writing a kind of pseudocode, okay? And then it's a very much related to the actual code, but I'm not following any language. We'll do that when we write the code in IDE. Okay, we have str, we have, let's call it index, int index, int index. Then we have int zeros, comma, int ones. Okay, so now what will happen is that we will check if zeros is equal to 0, which means there is no more 0 left. We will simply run a loop for int I equal to 0, I less than number of ones that is remaining, I plus plus, and I'll simply put str plus equal to 1. Okay, and after this loop is over, I'll simply print my str. Okay, now, and I'll return. Now what happens is that similar thing, we check for ones. We check if ones equal to 0. We run the same loop for I equal to 0. Let's make it int I less than ones, sorry, I less than zeros, I plus plus, str plus equal to 0. We print str and we return. Okay, I'll close this particular condition. Now let's say if zeros is not 1, ones is not 1, what are the options we have? We put str plus equal to 0, BINARYNUM, str, comma, index plus 1. So here we are not using index, but we are using this. But let's say if you are coding in C or C++ or any language in which you want to use the character array, especially in C you'll have to use the character array, you can simply do str index equal to 0. Here you will have to use the index, so that's why we took index as the parameter. Okay, we'll just increase the index, and then we'll make the number of zeros as zeros minus 1, and we'll let the ones be as it is. And here we have then str plus equal to 0, 1, and we have BINARYNUM str, comma, index plus 1, comma, ones minus 1, comma, sorry, zeros minus 1, comma, ones, zeros, comma, ones minus 1. So that will be my code. So half of the part is here, half of the part is here. So right now I'm using a thicker pen volume because I was getting a feedback that the screen is not visible. So I'm still getting into the habit of writing small characters. So anyways, so just try and understand this particular thing, and anyways we will write the complete program. Okay, so we'll write the complete program properly, but before that I really want you to do this on your own. Try and feel the logic. There's no use if you don't feel the logic exactly and you have the confidence that you are understanding everything. If you have a single doubt, make sure you do it again, okay, and make sure you dry run this particular program. And anyways we are going to write it in the language, but before that make sure you write this on your own. You run your code, dry run this thing, do the recursion tracing, make the stack, make the recursion tree, and understand this thing completely before you go ahead and write the code. And make sure after this you can write your code on your own. Though I'm writing the code, but make sure you write your code on your own and you run it and you submit it. Okay, so let's just go ahead and write the code. Okay, now let's just see the C implementation. So I have written the code over here. So in this case, here we have T as the number of test cases. Here we are taking the input. Here we simply running a loop for the test cases. Then we keep the variables ones, zeros and count. So we will need this count over here. We'll see where when is basically keeping the number of ones that we have in the number. Zeros is counting the number of zeros initialized with 0, both of them. Then we take n as the input. Then this is the code to convert the n into the binary form. And while we are converting this into the binary form, we are just keeping track of the number of ones we are getting and number of zeros we are getting. And then we have the count. So count is basically the length of that particular string. So in this case, then we have a character array binary. We are keeping one extra for the null character. Okay, then we have the permutation. So this is the function that we are going to call again and again. Basically this is the recursive function. We are passing the number of ones, number of zeros that we have, the string binary that will be taking care of the complete representation, and then we have count, and then we have 0. So basically this 0 is nothing the index. So as I said that we'll be taking care of each and every index where we are filling the value. Obviously it starts from 0. Okay, so now this is how my main function looks. Let's just go ahead and see the permutation function. So now this is my permutation functions. So as you can see, this is my permutation function. This is the code that we have, that if number of ones becomes 0, what we will do is that we will have binary index plus I, which means that let's say if my array is something like 0, 0, now my index is at this particular place, right? This is my index, and now what I'll do is that I'll start from I equal to 0 to the number of zeros or 1, whichsoever is remaining. In this case its number of ones is 0, so number of zeros are remaining. In this case it will be number of ones that are remaining. So whatsoever number is remaining, I'll go from 0 to that particular number, and it does index plus I. So let's say initially index is at this particular place plus I, which is 0, so it will point to this, then it will point to this, and we will just keep on filling the value 1, 1. Or let's say in case it would have been the other ways, we would have filled 0, 0. Okay, so this is doing the task of filling the number of zeros. So let's say if it is something like that 1, 1, then this whole place will be filled with 0 and 0. And after we have done that, what will happen is that we'll simply print this particular thing and we will return. Okay, so what will happen is that after we return from here, we will return to this particular place. Okay, now let's see, we have now the same thing goes for number of zeros. If the number of zeros is 0, then what will happen is that we will do the same thing, but now we will fill our ones. Okay, so now let's say if this is not the case, we have number of ones also remaining, number of zeros also remaining. In that case, what I'll do is that I'll print the place as 0. Okay, so let's say if this is my place, let's say we have 0 and 1, and let's say at this particular place, what we will do is that we will do 0. Okay, now I'll call the function again. Here I'll reduce the number of zeros. Let's say I go here, let's say only number of zeros and ones were 2, 0 is already over, I'll print 1 here. Then what will happen is that I'll print 1 here, I'll put 1 here, this complete thing is printed, and we return. After we return, we go back here. We go back here in terms of index, we come here in terms of our code, and what will happen is that this place is now getting 1. Then we again call this particular function. We come back here when we call this function. Then again we check if number of zeros and ones are remaining. If yes, things will be done accordingly. Okay, so this is the code. We have already seen how we have come across this particular code, and I also want you to dry run this code. Make sure you dry run this code. If you don't know how to dry run the code, dry run a recursive code, make sure you watch other video which is how to dry run a recursive code. But in case you were not able to solve this problem on your own, make sure you dry run this code. Okay, now let's just see the C++ code. This is the main function here. We are keeping track of the number of ones and zeros. Here we are calculating we are basically having the binary representation of the number, and we are simply calculating the number of ones that are there and number of zeros that are there. We have a binary string. Basically this will be the one which will be taking care of forming all the permutations or storing all the permutations and printing accordingly. Then we have the permutation function that we will call. We are passing the number of ones, zeros, and the binary string. Let's see how this particular thing works. So here we have the permutation function over here. Again, these are the parameters we have passed. Here what we do is that since we saw that we check that if number of ones are coming to an end, we fill rest of the places with 0. Similarly here we check that if number of zeros are coming to an end, we fill rest of the number places with ones. Okay, so once you have done this, so let's say if my string would have been like 1, 1, okay, and the number of ones and zeros are just 2 to each. So after we are done this, we will come here, we'll check number of ones are 0, yes, we'll fill rest of the places with 0. Okay, now here what happens is that when we return from this particular place, we come back to this particular place. Okay, we come back to this particular place when the return happens. So it's really necessary that you understand how the recursion thing is working. That's why I asked to try run the code again and again. We come to this particular place. Okay, anyways, so now here similarly we have number of zeros equal to 0. So we have 0 0. Let's say we have two places left, we'll simply print 1. Now in this case, let's say none of these are true. What we did was that we are calling the permutation function again. First, I have to put the 0th, okay? So I keep my number of ones as it is, I decrease the number of zeros, and I simply add 0 in the string. So if, let's say if it is something like 0 and these 3 places are empty, I put 0 over here, okay? So now let's say what happens is that we are at a place where we were like we did 0, 1, 0, 1, 0, let's say for that matter. Okay, so let's say we have done that. Okay, so now what happens is that we saw that first we were trying the 0th combination. So let's say we had a string, it had let's say 0 and 1. So we tried 1 and 0 over here, 0 and 1 over here. Okay, so now let's say once I have put 1 over here, what is the other what does happen? So what happens is that once I'm at this particular place, we return back to this particular place. Okay, we return back to this particular place. Now I have already tried 0 here, I have to try 1. So this particular thing takes care of that. So what happens is that when we come here in terms of the string, and we come here in terms of the code, and this particular part of the code, it gets executed. So now what I'll do is that I'll put my 1 here. Okay, I'll put my 1 here, and then I'll reduce the number of ones, and the number of zeros remain as it is, and my binary will be like this will be here. And now again this particular function gets called, put 0 here, and again what will happen is that we come here, since the number of ones is 0, simply the binary gets printed. Okay, and then this is how the recursion will work. Okay, now let's just go ahead. So as I have said, I'm saying again and again, make sure you dry run this code on your own to understand the things better. So now this is our Java code. Here we are taking the input. Now here what we have is that we have the loop. We are taking the ones and zeros as 0. Basically here we are calculating the binary representation, and we are just calculating number of ones and zeros in the representation. Okay, then we have this string binary, which is taking care of the string that we are going to print, and then we have the permutation function, or you can call it permutation method. Let's just quickly see this method. So we have already seen how we came across this code. We are just seeing the implementation in this particular case. Here we simply see that now if number of ones become 0, we simply fill rest of the places with zeros. Here we check if number of zeros become 0, we simply fill with rest of the places with 1, and this is the recursive call. As we saw that we will for every place we will try 0. When we are trying 0, we will simply reduce the count of 0, and then once we have tried 0 for the places, then we will try 1, and when we are trying 1, we reduce the number of ones as 1. Okay, so make sure, I am repeating, understand the code, dry run this code. If you have not done this code on your own, dry run, because that is very necessary. That is when you understand the things about it. Okay, so let's just submit this code and see if we are getting the right answer. So we got the right answer. Make sure you try this code on your own, and you practice other questions also. For practicing other questions, you can simply go to the dashboard, you can go to the practice mode, you can simply go to the recursion, and you can solve the problems. Okay, all the very best.